From the video, it claims that intelligence power saver consuming more current rather than saving current. Second claims, this device increases the monthly electric bill, which means it consuming more power rather than saving power. Third claims, the devices are consuming power as 1 horsepower air conditioning to the customer. To support the claims as stated from the video, the electrician from the video used a multimeter to test out the current flow in the TMB meter. Results shown that the current increases when the devices are switched on, but the current decreases when the devices are switched off. This testing is conducted with all the home appliances and devices are switched off. Therefore, we have conducted a lab experiment in order to prove that the claims are either rejected or accepted. This experiment is to bring out a more accurate and specific explanation about the effectiveness of intelligence power saver. Moreover, this experiment can perform better accuracy of the parameters reading as the apparatus used are more advanced than the multimeter used in the video. The objective of this lab experiment is to find out whether the intelligence power saver is able to save energy. Moreover, to prove that the claimed intelligence power saver is consuming more current is accepted or rejected. Furthermore, to prove that the claimed intelligence power saver is increasing the monthly electric bill.
Hello everyone, after we have watched the video from Backup Electric, we found that he claims that this device, Intelligent Power Saver, is consuming more current and increase the monthly electric bill. However, after we have done the experiments, we found out that it is consuming more current, but it will not increase our monthly electric bill. The objective of this experiment is to test whether this device, Intelligent Power Saver, is able to save energy. So now, let us bring you to go through our experiment.
As you can see from here, inside the device it consists of one capacitor bank and also some resistors. And the value for the capacitor bank is 3.0 microfarad. Okay. As you can see from here, this is our experiment setup, and this is the oscilloscope to analyze the waveform. This is the resistive load, inductor load, and we will use 4 devices to conduct our experiment. Then here is our energy analyzer. Firstly, we will connect our circuit with the resistive load only, and this is the waveform. The yellow is the voltage, blue is the current, and red color is the power. As you can see from this waveform, they are in the same phase. And the current RMS value is 2.3 something, and the voltage is 0.55, the reactive power is 0.04, and for the power factor is roughly to unity 1. And now I will switch on the 4 devices. And let's get back to the waveform. As you can see, the current waveform has shifted to the left, which means leading, and the current has increased to 2.5 something. And as you can see from here, the reactive also increased, but the power remained the same, and the power factor has decreased. Why this kind of situation happened? Because of the equation P equal to VI cos theta. The voltage is constant and the change is the current and cos theta. The power factor, the cos theta is the power factor which has decreased, and therefore the current has to be increased, and then only the power is constant. Okay, next we will conduct our experiment with connect our circuit with the resistive and inductive load. Okay, so with the 4 devices switch off, the waveform is as shown here. The current is lagging behind the voltage, and the current value RMS is 2.03, the power is 0.44, the reactive power is 0.26, while the power factor is 0.8. Now I will switch on the 4 device. As you see from here, the lagging current has shifted to the left as it's now is same phase to the voltage waveform, and the current RMS has dropped to 1.8. The reactive power has dropped to 0.03, but the power is still remain the same, and the power factor has increased to almost unity as the waveform is in same phase. Why is this happen? Because according to the equation, P equal to VI cos theta, which the cos theta is the power factor and I is the current, the voltage remain constant, and therefore the change is only current and power factor. When the power factor increase, the current decrease. Therefore, the power is still remain as 0.43. As you can see from here, now we only connect the 4 devices in this circuit. And the waveform shown that there is a current flowing in this circuit. It is true that the video said that this device increase the current in the circuit. However, there is no voltage in the circuit, which means that it does not consume power consumption. And you can see from here, the power value is almost equal to 0. Therefore, to contrast the video, this device does not consume power in the circuit.
Recently, we found out there are many kinds of power-saving devices in the market claiming that this device can save energy in our home and reduce our monthly electricity bill. However, after we have carried out our experiment, we have made a video to give the society a better understanding on the characteristic and function of the power-saving devices. In this video, we explain about the main components inside the power-saving device, which is a capacitor. It can help to improve power factor, but it cannot change the value of power consumption. Besides, we are also able to raise the awareness of the public that power-saving device is unable to save energy and monthly electric bill. This is because TNB only charges us on the power consumption at domestic area, which is equal to the equation P equals to VI cos theta. The capacitors can only change the power factor, which is the cos theta, and the current. So when the current increases, the cos theta decrease. They will balance out, and therefore the value of P will remain constant. Therefore, we are able to reduce the number of public being cheated by the manufacturers of power-saving devices. In conclusions, it is proven that the intelligent power saver is unable to save energy, and the monthly electricity bill will remain constant. This is because the power consumption as shown in the energy analyzer remain constant after the power-saving device are connected to the circuit with R load and RL load. This is due to the equations of the real power P equals to VI cos theta. When the value of I increases, cos theta decreases, while when the value of I decreases, the cos theta increases. It will balance out and the value of P remain constant. On the other hand, the waveform of the circuit shown by the oscilloscope shows that the intelligence power saver can cause phase shifting, which is current leading to voltage. This is because the device is made out of capacitors which can act as a power factor corrector. However, when only the intelligent power saver is connected to the circuit, we can see that the intelligent power saver also acts as a load which consumes more current. However, it will not increase the power consumption because no voltage is consumed. Therefore, P equals to 0. Lastly, we should always consume the power wisely to save our environment but not depend on any devices. All manufacturers of power-saving device should put in efforts to design a device which can really reduce the power instead of current, and therefore can benefit the society.
In conclusion, this device will affect the power factor which caused by the phase shifting. Therefore, the change of the current does not prove that it will increase the power consumptions and increase the electric bill. This device is only changed with the current and power factor, but the voltage and power remain constant. Lastly, the intelligence power saver will increase or decrease the current but will not consume power. Thank you.